We say that the 5G core network is a service-oriented core network. What does it mean? It means that first, this core network can accept all kinds of access, radio access. It can accept not only 5G, 4G, 3G, or 2G, the standard 3GPP network. It can also accept access from other types of radio network. This first thing, it can accept all kinds of radio access. And it can provide all kinds of services, like voice, video, okay, some autopilot, okay, industrial manufacturing, and so on. Okay, different services. And different services need a different requirement of the network. For example, for the video service, we need more bandwidth, throughput. Okay, and for the autopilot, we need low latency. So different types of service may need a different feature of the network, function of the network. Okay, so for 5G network, our network function, or say our capability, is very flexible. It can be programmable. More functions can be supported, okay, programmable, and we can combine different capabilities to one pipe. This pipe we call it slice. Okay, this function is very flexible, and also their combination is also very flexible. We combine some functions to form one slice, and this slice can support wide types of service. Got it? Yeah, this is the meaning. Okay, so we have very flexible architecture and a very flexible capability to form different types of slicing. Okay, slicing just means that we combine different features of the network. Okay, to divide our physical network into logical subnetworks to provide different services to different subscribers or to different customers. Okay. So to realize this feature, we may need this CUPS. Okay. CUPS means control user plane separation. Okay. We can separate the control plane and the user plane. And the user plane's deployment is very flexible. Okay. And we will elaborate this a little later. Also, SBA, a service-based architecture. Our network architecture is based on the service. You have this kind of service, we need some of this component. Okay, you have some others types of service, we can have another types of combination of the architecture. Okay, so it's service-based architecture. And by slicing, by slicing this way, we can cut our network into different slices to support different services to different users or different customers. Okay. And the core network is native cloud. That is to say, this core network is cloud network. Okay. So this is about this service-oriented core. And why do we need the slicing in 5G? First, let's look at 4G. 4G is a 4G network. 4G network. We may have different types of services, like mobile broadband, like this automated driving, like some Internet of Things. These are three very different types of services. This, we say, is mobile broadband. This one, we need a very low latency. And this one, we need huge number of connections. Okay. So they have different requirements for the network. But for 4G, it's just one 4G network, providing services to these services. And they have a similar performance. In fact, this 4G network cannot adapt to all service types because it do not have this kind of capability to cut this network into different subnet and provide different capabilities to different services. So this is a 4G network's shortcoming. For 5G, we also have these 3 different types of services, but we can cut this network into different logical subnetworks. Now, this is one physical network, one physical network, one physical 5G network. And we can cut the resources into different pieces. Each piece is just one slice. Okay, let's say one slice for this Internet of Things, okay, IoT. Another slice for this, for URLLC, okay. Another slice for this eMBB, okay. And they are composed by different functions. Okay. So they can adapt to different service type. Okay. So this is the why we need this slicing. First, we can cut the network to support different services. This is the first point. Second point is that we can also provide a service to different subscribers, to different clients. Okay. And we say that 5G can enable the industry digitalization. And there may be more and more enterprise subscribers. Okay. Maybe one enterprise subscriber can just use one slice, okay, for a group of users. Okay. Now, so this is the why we need this network slicing in 5G. To realize the slicing, our core network function is programmable. Okay. You can see these are some some functions which are programmable. This is blue color is for user plane, like a codec for video, okay, coder encoder or decoder encoder, okay, for video, okay, TCP for downloading, okay, downloading, and that is for user plane, and this one is for control plane. For example, for registration, okay, we switch on the phone, we need to have the registration to the network, okay, mobility management, security management, okay, and authentication and so on. This one, okay, is for the control plane. So these are different functions that are programmable. And we can deploy these functions to the network. Now, you can see this network, we can have this edge DC, local DC, and center DC. DC means data center. Data center. Data center, we just have some equipment room, and there are many servers inside, okay? So edge DC is near to the site, near to the base station, near to the terminal, okay? And the local DC usually is just one city, okay? And center DC usually is in the capital of one region or province, and so like those things, okay? Center DC. Let's take one example like this IOV, okay? This slicing, okay? IOV means Internet of a Vehicle, Internet of Vehicle. This one needs a very low latency, very low latency. So we can deploy our server at the edge DC, apply this server and the reliability function, okay? You can see this is one kind of function. And this is server, okay? We can deploy it near the user side. This can reduce the latency. Sure, it's very near, okay? And for some other, for example, for video service, okay, we can deploy this video resource, okay, in the local DC, because if the video is in the center DC, then there may be many downloadings, and then we need a big bandwidth between them. And if we distribute the video in the local DC, first it can reduce the responding speed. Second is it can save the bandwidth, okay, between the local DC and the center DC. Okay, so this are the two aspects of the flexibility of this. One is a programmable function. Second is also flexible deployment of the position in the edge, local, or center DC.